that we've learned all these different ways to factor, sometimes you wonder, how do I decide where to even begin whenever I'm looking at them? So I have a couple steps here for you. First thing, always check to see if there's a greatest common factor. If there is a greatest common factor, factor it out. Remember, you always leave it as your greatest common factor. Put in parentheses whatever you have left over. Then check and see if there's a pattern. If there's a difference of squares, remember if it's a squared minus b squared, it would factor to a plus b times a minus b. Check to see, is it a perfect square trinomial? Do you have a squared minus 2ab plus b squared, or a squared plus 2ab plus b squared? Because remember, this would factor to a minus b squared. This would factor to a plus b squared. Don't forget about those. Then go ahead and straight factor and check for a common factor. So let's go ahead and let's start trying some. We're going to factor these completely. The first thing I'm going to look for in number 1, is there a GCF? I'm going to look at each factor. In the first factor, I do see a GCF of 5. So I'm going to factor out of the first one 5. So I would take the 5 out of each to get 5 times the quantity x plus 3 times the quantity 3x minus 4. Check each factor. Can 5 be simplified any further? No. Can x plus 3 be simplified any further? No. Can 3x minus 4 be simplified any further? No. So you know that you're done. Always keep asking yourself, can I factor more? Can I factor more? Can I factor more? Number 2, the first thing I noticed, all of the terms were even, so I knew that I would have a greatest common factor of 2. So when I take the 2 out, I'm going to see what do I get left over when I take 2 out of each term to put it out front. I'd have x squared plus 6x plus 9. Then I'm going to look here. Okay, is this something that I can factor? X squared plus 6x plus 9. Oh, x squared is a perfect square. Yep. 9's a perfect square. Yep. So is the middle term twice the square root of each? Yeah, because the square root of x squared is x, square root of 9 is 3, 3 times x is 3x, times 2 is 6x. This is a perfect square trinomial. So it would just factor to, if I were putting this in the format, just over here some scratch word, x squared plus 6x plus 9. A would be the square root of x squared, which is x. B would be the square root of 9, which is 3. And then 2ab is 6x. So it is. So remember, when you factor that, you'd have 2 and then x plus 3 quantity squared. Could you have factored this and said what multiplies to be 9 and adds to be 6? Absolutely. But if you had 2 times x plus 3 times x plus 3, then you would need to simplify it to 2 times the quantity x plus 3 squared. Number 3, we're still factoring completely. Again, the first thing check, is there a GCF? There is. There's a GCF of 4, but they all have 2 x's in them, so 4x squared. So this time, when I start factoring, it's going to be 4x squared times, let's see what we get when we factor out our 4x squared out of everything. 4x squared divided by 4, or 4x to the 4th divided by 4x squared is x squared minus 3x plus 2. So I'm going to go ahead and make my little chart to see if I can factor that. So I would need to look at the factors of each of these x and x. The factors of 2 and 1 are 2. Are there any way that these can add to be negative 3? Absolutely not. It cannot factor anymore. So you know you're done. You always have to try to factor the inside. Try to factor, but it won't always work. When I look at 4, there is no GCF, so I can skip that. No GCF. Is it a special trick? Is a to the 4th a perfect square? Yes. Is negative 6 or 16 a perfect square? Yes. A to the 4th and 16 are perfect squares. Because they are perfect squares, the square root of a to the fourth is a squared. The square root of 16 is 4, so it's a squared plus 4 and a squared minus 4. Look at each factor. Can I factor a squared plus 4 anymore? They are perfect squares, but remember, it has to be a difference, subtraction. This is addition, so I can't do anything there. But aha! A squared minus 4 is the difference of two perfect squares. So I couldn't do anything with a squared plus 4, so I brought it straight down. But a squared minus 4, it could factor to a plus 2 and a minus 2. Now I'm going to check. A squared plus 4, we already said that was done. A plus 2, nope. And a minus 2, nope. So you know that you are done. Okay, for this next one, I have some directions on here. You're going to be trying these on your own. They say tell whether the polynomial is completely factored. If not, factor it. Hit pause and write the polynomials down. Factor on your own. If you're having any problems, simply go through each question and with the videos. Press play to check your answers. If you need to go through a question, keep watching the video and each example will be explained. So here are all the questions. And now hit pause, but I'm going to go through them. Don't hit unpause until you try them on your own. Number 1, you have two factors. 3x squared, I cannot factor anymore. 6x minus 4, that has a GCF of 2. So my 3x squared has to come straight down, times my GCF of 2, times, what do I get when I factor 2 out? I get 3x minus 2. But I'm not done yet because I can simplify this. 3x squared times 2 becomes 6x squared because it's a monomial times a monomial. Remember, monomials times monomials, multiply the numbers, add the exponents, times 3x minus 2. Number 2, x squared plus 1. This is not a difference. It cannot be a dots because it is addition. And there's no GCF. X minus 4, it's not a difference of two squares. It's not a trinomial, so I'm actually done. You could say cannot factor further. Cannot factor further. Number 3. The first thing that you should have noticed for number 3 was there's a GCF. The greatest common factor for 3 was 2. So I'm going to go ahead and rewrite it. 2 times the quantity, divide the 2 out, take the 2 out because I put it out front. You get 5x squared plus 24x plus 16. You need to look on the inside. Can I factor this further? So I'm going to do it by slide and divide. Could you do it by guess and check? Absolutely. So remember, for slide and divide, if you have 5x squared, I'm going to do it in a different color actually, so that we can see it and say this is just my scratch work. My scratch work's in pink right here. A 5x squared plus 24x plus 16. So remember, you take your first number and you slide it to the left, right. So you have x squared plus 24x plus 16 times 5 is going to be 80. 5 times 10 is 50. 5 times that is there. So I want to think, what are the factors of 80 that would multiply to be 24? So the factors of 80, well, it's obviously not 1 times 80. 2 times 40. 80 is not divisible by 3. 80 divided by 4 is going to be 24. Ooh! Look at it. Oh, I mean, it's going to be 20, which when you add them becomes 24. I got excited. So it's positive, so it's x plus 4 and x plus 20. With the name slide and divide, so since I multiplied by 5, I have to divide by 5. I can't simplify 4/5, so I have x plus 4/5 times x plus 4. But remember, last but not least, kick up the 5, and you get 5x plus 4 times x plus 4. So this could factor further. I'm done with my pink scratch work. My 2 came straight down. This factored to 5x plus 4 times x plus 4. It got really exciting because you could factor it. I looked at each other term, and neither of them could go further. 5x plus 4 cannot factor further, and x plus 4 cannot factor further. So let's take a look at number 4. When I look at number 4, I am going to go ahead and erase everything for number 3 because you have it already. Just so we have some room. For number 4, there is a GCF. I look first at the numbers 8 and 18. The biggest number that goes into both of those is 2. X to the 6 and x squared, they both have an x squared. Y squared and y squared, they both have a y squared. So I'm going to factor out my GCF, 2x squared y squared, and see what I have left over. So divide each by 2x squared y squared, divided by 2x squared y squared, and you end up with 4y squared minus 9. Ooh. GCF can't factor further, but I notice 4x squared minus 9 is a difference, because it's subtraction, of 2 perfect squares. The square root of 4x squared equals 2x. The square root of 9 is just 3. So I can factor that to 2x plus 3 and 2x minus 3. Notice your GCF, 2x squared y squared, comes straight down. Cannot factor further. 2x plus 3 cannot factor further. 2x minus 3 cannot factor further. And you're done. Number 5 is a really good one. Number 5, I notice there is a GCF, and it's just p. So I factored my p out to get p to the 4th minus 1. But look at, they're both perfect squares. It's a difference of 2 squares. The square root of p to the 4th is p squared. The square root of 1 is just 1. So that factors, your regular GCF of p comes straight down. P squared plus 1, p squared minus 1. Again, right here is a difference of 2 squares. The square root of p squared equals p. The square root of 1 equals 1. That's an addition, so that does not change. So I'm going to bring my p down. Can't factor p squared plus 1. But this factors to p plus 1 and p minus 1. So it kept going, kept going. P cannot factor. P squared plus 1 is the sum of 2 squares. It cannot factor. P plus 1, nope, they're not even perfect squares. P minus 1, nope, they're not even perfect squares. So you know you factored it the furthest. So remember when you're doing them, first, is there a GCF? Remember, if it's a binomial, check for a difference of 2 squares. Look and see, is it a perfect trinomial? Go back and check. Factor completely.